Alright, this is Linux Server Management Assignment 3. I've set up two Rocky Linux VMs, one as a server and one as a client, and they're communicating over a private network. I've configured DHCP for dynamic IPs, NFS for file sharing, centralized logging, NTP for time sync, and tested backups. And I'm going to show each component. Alright, so as you can see, I went ahead and named my Rocky server to keep it nice and simple for myself. And my IP addresses are 10.10.98/24, obviously, for my ENS 160, and for ENS 224, you can see it right here. And here I am on my client, and I've named it Rocky Client, just like the other one, nice and simple. And here are the IPs I'm working with on my client. Then this is my config file on my server, and we can see the subnet here, and then we can see the range. It's assigning the IPs in the range of 21 to 30. And we can see it's setting the router here as 192.168.9.2. And we're using Google's DNS servers as usual. And here we can see that my DHCP is enabled on boot. And here we can see it running. So there's the DHCPD process running with the PID and the config file it's using. So here we can see the firewall rule and the command I used to add this rule. And then we can see that DHCP listens on UDP port 67, and the 0.0.0.0 means it's listening on all of the interfaces. So now I'm going to demonstrate the client receiving an IP from the DHCP, and I'm going to use the TCP dump. So this is my config file on my client, and this is configured to use DHCP auto mode on the second NIC. I'm going to restart it to trigger a fresh DHCP request so we can see the conversation on the server. In the DHCP dump output on the server, we can see the client broadcasting and the server responding, and the client requesting, and then the server responding. And here we can see the client got 192.168.9.26 from our DHCP server, and that's in the correct range. Now for the NFS server setup, you can see that NFS utils is installed, and this is the command that I installed it with. And here we can see it's enabled and running. And we can see that multiple NFS daemons are running. NSFD handles the file requests. RCP bind manages the RCP services. And here we can see the firewall rules I added, and then down below are the commands I used to add the rules. So here we can see that I'm exporting /public share to the 192.168.9.0/24 network with read-write access, and it's in sync mode, so changes are immediately written, and then the no_root_squash, so the client can modify the files as root. And here we can see that the export was applied. So the directory exists with world writable permissions, so both the client and the server can write to it. And then here we can see the cron backup job. So every day at 2 a.m., this cron job runs a backup script that copies the /public share to a /backup, and it comes with a timestamp folder name. So here you can see the super simple script. The script copies the directory, creates a timestamp backup folder, and automatically deletes backup folders older than 7 days to save space. So here we can see that NFS was indeed installed on my client, and we can see show mount, which is listing what server is exporting, and we can see that public share is available. And here we can see the successful mount on my client. So we can see this line in the fstab that's ensuring that NFS shares mounts automatically on boot. The default option is using the standard NFS settings. So here I'm going to create a test file just to show that everything's working properly. And there we can see that file. And here we can see the file was created on the server, sorry. And here we can see the file was created on the server. Just for more proof here. So moving on to centralized logging, here's my rsyslog config file. I uncommented two lines in the rsyslog.conf file. One loads the UDP model and listens on port 514, and the other loads TCP. This is allowing remote systems to send their logs to the server. And rsyslog is listening on UDP and TCP port 514, and it's ready to receive logs from the client. And here we can see the firewall rules, and here is what I did to add these rules. So I'm going to use this tail command to start monitoring the logs on my server. So here's my rsyslog config file on my client, and you can see that I added one line here at the bottom. The asterisks mean all facilities and severities, and the @ symbol means send to that server via UDP. So here we're going to send a test message from our Rocky client, and we're going to go see if it's working in our server. And here's a test message from the client showing up in the server's logs, and it's showing that centralized logging is indeed working. It's time for the time synchronization. The server gets time from internet sources and provides time to the client on the private network. So here we can see the server is syncing to multiple internet time servers. The reach column shows 377, which is good. So here we can see my Crony config file. I added two lines, allow 192.168.9.0/24, which lets the client network sync to the server, and local stratum 10 serves time even if the server isn't synced to the internet. Here we can see my firewall rules with NTP listed, and then here down below is the command I used to add that rule. And here we can see the client at 192.168.9.26 is syncing to the server. So here's my Crony config file on my client. I commented out any of the default pool entries and added server 192.168.9.2 iburst, which tells Crony to only use my server as the time source. So here we can see the date and the time date CTL command on my client, and here we can see it on my server. And here we can see my time zone is PST on my server, and the same for my client. And we can see this TCP dump shows the NTP synchronization packets between the client and the server on port 123. So for the backup component of the assignment, I kind of just made full copies of the entire server's VM folder to my external drive here, and I just kind of stamped them with time so I know exactly when they're from. So you can see it includes the VMX config file, the virtual disk file, and all the BIOS settings. To restore it, I copied the backup back to my VM's folder, and I opened the VMX file in VMware. It asked me, did you copy this? I clicked, I copied it to reset the VM ID. Then I powered it on and verified everything worked. All services were running, the IP configs were correct, and all my data was still there. So in the future, if my VM ever got corrupted or deleted, I could just recover it from this external backup, and it would only take a few minutes. Something I took out of this assignment was that I'm actually starting to really like Rocky, because I just felt like everything ran just a lot smoother and simpler than in Fedora for some reason. Maybe that's just a fluke, but that's what I found for this assignment.